researchers have created an ultra-flexible screen that conforms to the surface of your skin. The skin-like transparent display can attach to fabrics and other non-flat surfaces without becoming damaged, overcoming previous technological barriers at a much lower cost. This breakthrough could one day help to improve the capabilities of wearable devices and augmented reality. Earlier efforts have attempted to use inorganic-based electronics, but such materials have fundamental limitations to the high-temperature process, according to the researchers. But the team from the Korea Advanced Institute of Science and Technology used a method known as inorganic-based laser liftoff. This allowed them to work around the issue of thermal instability. Flexible transparent display is a promising candidate to visually communicate with each other in the future Internet of Things era, the authors write in the paper, published this month to Wiley's Advanced Functional Materials. The flexible oxide thin film transistors have attracted attention as a component for transparent display by its high performance and high transparency. The critical issue of flexible oxide TFTs for practical display applications, however, is the realization on transparent and flexible substrate without any damage and characteristic degradation. To create the ultra-thin display, they built a high-performance oxide thin film transistor on top of a sacrificial laser-reactive substrate. The substrate was irradiated from the backside, allowing the oxide TFTs to be separated from the substrate. These were then transferred onto ultra-thin plastics. This method allowed the researchers to develop ultra-thin oxide TFTs with high optical transparency of 83%. The display was then attached to the surface of human skin, demonstrating its flexibility and functional capabilities. According to the researchers, it proved to have a high degree of mobility, and survived several cycles of severe bending tests. Earlier attempts at this type of display were met with challenges, resulting in poor transparency and low electrical performance. But, the researchers say the use of the ILO method have provided a way to overcome these obstacles. This could make for wearable devices that are more flexible and have greater transparency. By using our ILO process, the technological barriers for high-performance transparent flexible displays have been overcome at a relatively low cost by removing expensive polyamide substrates, said Professor Keon J. Lee of the Department of Materials Science and Engineering. Moreover, the high-quality oxide semiconductor can be easily transferred onto skin-like or any flexible substrate for wearable application.